The theory holds that Earth should have previously been visited by aliens, since our solar system is very young compared to the rest of the universe, approximately 4.5 billion years old, compared to 13.8 billion, and that interstellar travel might be rather straightforward to achieve given enough time. That question was famously posed by the Italian physicist Enrico Fermi in 1950, and it is now known as the Fermi paradox or the Great Silence. Fermi questioned whether there are other civilizations in our Milky Way galaxy, and why we haven't heard from them, if any have spread around the galaxy, as both science fiction and scientists have speculated. Fermi understood that any civilization with a modicum of rocket technology and an immodest amount of imperial incentive could quickly colonize the entire galaxy. In fact, proponents of the search for extraterrestrial intelligence contended that every star system could be absorbed by an empire in a matter of tens of millions of years. Although tens of millions of years may seem like a long time, it is actually fairly young when compared to the galaxy's age, which is about 1,000 times older. Others, like Michael Hart, who published an article titled "An Explanation for the Absence of Extraterrestrials on Earth" in the Royal Astronomical Society Quarterly Journal in 1975, took up the task of exploring and explaining the theory when Fermi passed away in 1954. It's difficult to establish, but some claim this is the first paper of its kind to examine the Fermi paradox. We note that there are no longer any extraterrestrial intelligent entities on Earth. It is stated that the idea that our galaxy is home to no other advanced civilizations provides the best explanation for this fact. To more precisely identify the solution, more investigation into biology, planetary formation, and atmospheres was required. Hart contended that unless sentient aliens began their journey fewer than 2 million years ago, they could have already visited Earth at some point in its history. He reasoned that the seeming dearth of these encounters was probably caused by the absence of sentient aliens. However, he also listed 4 additional hypotheses that could be true. The physical challenge that makes space travel infeasible, which may have its roots in astronomy, biology, or engineering, is the reason why aliens have never visited Earth. Aliens have just decided not to come here. Beyond Earth, advanced civilizations emerged too recently for aliens to have contact with humanity. Although we haven't seen them, aliens have visited Earth in the past. Another concern is, if aliens are aware that we have a civilization on Earth, then why are they staying silent? Maybe they are observing us like we would a zoo of animals. How do we get the zookeepers in space to come clean? We would feel obligated to react if, while visiting a zoo, a zebra turned abruptly, met our eyes, and began pounding out a string of prime numbers with its hoof. This would create a very different dynamic between us and the zebra. By sending strong, deliberate radio broadcasts to surrounding stars that are rich with information, we may do the same with extraterrestrials. History demonstrates that any encounter between 2 civilizations is hazardous to both. Aware of this, intelligent aliens won't attempt to speak with us. Are we truly living in a space zoo? Being watched, but not up close? Alternatively, should we even be isolated from the rest of the galaxy? Extraterrestrials are probably enforcing a galactic quarantine because they understand that knowing about them will upset our culture. On Earth, the evolution of cognition has both random and predictable traits. We can anticipate the recurrent, autonomous emergence of intelligent organisms throughout the cosmos by taking into account both the regular and random components combined. Under the right circumstances, we should also anticipate seeing roughly comparable types of intelligence everywhere. There's no evidence to suggest that human cognition has progressed to its maximum potential. In the future, higher levels may evolve on Earth and may have already been attained elsewhere. At this point, everything is just hypothetical and depends on the still unknown number of actual civilizations. Although that number has been estimated using the Drake equation, other unknown variables still need to be taken into consideration. How many exoplanets are habitable by life? In reality, how many do? How frequently does sentient life change? In how many civilizations is humankind's level of advancement? The primary focus of searches has been to check for light or radio transmissions. Those technologies might be used by developing civilizations like ours. But what about a society that existed hundreds or even millions of years ago? Their technology would probably also be far more advanced. Not only might we not share much with them, but we might also share little with less developed societies. An exoplanet's environment will set its own regulations. There is no pattern in biological evolution, at least not for macroscopic complex life. Given the vast diversity of morphologies found on Earth, exobiological conjecture is unlikely. Some would claim that the UFO phenomena proves aliens have already discovered us. Although there is much disagreement on that topic alone, it is a thought worth taking into account because well-informed speculation regarding the Great Silence and the Fermi paradox implies that any civilizations that are developed enough to colonize the galaxy should already be aware of us. While misidentifications and hoaxes account for the vast majority of sightings, certain cases remain unsolved, including some well-documented military claims. Even though there is currently no evidence linking any of these occurrences to alien involvement, they are nevertheless intriguing and deserve more investigation, regardless of the eventual cause. Following up on Hart's argument, Frank Tipler, a physics professor at Tulane University, proposed a method for obtaining resources for interstellar travel, having some sort of self-replicating artificial intelligence move from star system to star system, making copies of itself along the way. Tipler contended that we are probably the only intelligent species in the universe because there has never been any indication of such sophisticated apparatus on Earth. He contended that people who believe in alien intelligence are similar to people who are obsessed with unidentified flying objects, UFOs, because both groups think that a miraculous interplanetary intervention will save us from ourselves. The study of alien intelligence is a hot issue these days, with several articles from various research organizations being published annually. Furthermore, the current exoplanet revolution has given rise to the possibility that advanced civilizations exist outside of Earth. The universe is very old and very large. The observable universe is around 92 billion light-years wide, according to data collected by a number of observatories and increasing faster and faster all the while. Furthermore, several data suggest that it is 13.82 billion years old. Extraterrestrial societies have had plenty of time to develop and disperse, but they probably need to travel across a huge cosmic chasm before reaching us. At the time of Fermi's well-known statement, astronomers were only aware of planets within our solar system. However, in 1992, pulsars' superdense stellar corpses were discovered to have planets orbiting them by scientists. And the first confirmed exoplanet around a sun-like star came up a few years later. Over 5,000 exoplanets have been confirmed thus far, and more are discovered annually. The sheer quantity of extraterrestrial worlds raises the possibility that there is plenty of life elsewhere in the universe. Scientists will eventually be able to examine the chemical makeup of the atmospheres of certain neighboring exoplanets because to advancements in telescope technology. The closest known exoplanet is located approximately 4.2 light-years away, or 40 trillion kilometers away. The ultimate goal is to determine the frequency with which rocky planets develop in the habitable zone of their parent stars, which is the range of orbital distances where a planet's surface can support life. But habitability is more than just water. The activity of the host star and the makeup of the planet's atmosphere are two further variables that need to be taken into account. In addition, there are other factors that contribute to the habitable zone's conventional definitions growing perceived oversimplification. For instance, frozen moons in our own solar system, like Europa on Jupiter and Enceladus on Saturn, are located well outside of the habitable zone, but may still support life in their subterranean seas. However, Sun-like stars make up a small fraction of stars in our galaxy. Red dwarfs, or tiny faint burners, make up over 75% of Milky Way stars. Numerous rocky worlds have been discovered by astronomers orbiting red dwarfs in the habitable zone. Proxima b is one such example. However, because red dwarfs are quite volatile, especially when they are young, it is unknown how habitable such planets really are. Therefore, young habitable zone red dwarf planets may see their developing atmospheres swiftly destroyed by stellar outbursts, making it very difficult for life to establish itself there. To fully comprehend these stars and the possibility of life surviving around them, more research is necessary. Since bacteria can endure in harsh conditions, studies conducted on Earth have led to the possibility that microbial life exists on Mars, Europa, Enceladus, and or Titan, the massive satellite of Saturn. However, none of those planets have been investigated quite well enough for us to be certain. But the Fermi paradox is thinking much beyond microorganisms. In order to find a solution, we must ascertain the frequency with which extraterrestrial life emerges, as well as the frequency with which it acquires the capacity and inclination to interact with other sentient beings or travel among the stars. There are no simple answers when it comes to the Great Silence, at least not yet. However, approaching the problem from a multidisciplinary perspective is an intriguing method that could result in something much more intriguing. This is due to the fact that information from a variety of scientific domains will be needed in the search for alien intelligence.